everybody, this is section 2-3 from our Hawks Learning College Algebra textbooks for Math 101. We will be looking at quadratic equations with one variable here and solving using various different methods. Along with this video, I will post other videos to help out review. There's a lot of information in this section, and this is a section that we will spread out over 2 weeks or 2 class periods so we can get it all in. All right, so the first thing we're going to talk about is just what a quadratic equation is. Remember, a quadratic equation in one variable is an equation that is raised to the power of 2. So we solved linear equations in the past where they were variables that were raised to the power of 1, or just like x or y, z. Now, our variable in a quadratic equation, the highest degree is a degree of 2, or the variable is squared. And those are called second degree equations. And a quadratic equation, if you recall, when you graph a quadratic equation, your graph is going to look like kind of like a U shape. It's called a parabola. So when we graph a quadratic equation, you have a parabola shape. And we'll look at that as well. The first way that we're going to look at solving quadratic equations is through factoring, and hopefully factoring is something that you remember from previous courses. It is a skill that you should already have coming into this class, but we will review it and go over it, and again, I will post some extra videos on factoring if you're not sure how to do it. One thing I will say with factoring is there are multiple ways to factor a problem. So the way that I teach you, which I use the box method because I feel like students learn that way the best way, understand it the most. And that's just, again, just from years of teaching, what I've found students do the best with, but you may be different. You can factor either by grouping. Some people use like the diamond method to factor. Some use guess and check. It's up to you how you factor, how you arrive at those two binomials. It does not matter to me which way you do it, as long as you can show your work and you get the correct answer in the end. So again, if you don't like the way that I show you, you do not have to use that way. You can use any way you want as long as you get the correct answer. And what we're going to do is once we factor our quadratic equations, they should factor into most of the time 2 binomials. Sometimes if it's a higher degree, it will go to like 3 or 4, but we should have 2 binomials for a quadratic. And when I write those, if I just, and again, I'm just making this up. Let's say I factored it and I had x plus 2 times x minus 7 equals 0. And that was my factored problem. That is going to, A is going to be represented by x plus 2. B is going to be represented by x minus 7. And what we are going to do is all quadratic equations, before we solve them, they have to equal 0. So what I can do is they're saying is, well, if A times B is equal to 0, that means that either A, or in our case, x plus 2 equals 0, or B equals 0. So x minus 7 equals 0. And what you do is once we factor, we split it up into 2 equations. So we have our x plus 2 and x minus 7. And then we solve those equations to figure out what x would be. So for like this one, I would subtract 2 and I get x equals negative 2. Here I would add 7 and I get, I'm going to write it up here, x equals 7. And then when we go to write our answer, because we have 2 answers, we're going to write it in set builder notation or roster notation. So I do negative 2, 7 in the brackets. All right, so the next couple slides we're going to look at factoring, and then we're going to solve some questions like they are in the book, and then we'll move on to a different way to solve problems. All right, so what we are going to do is we're going to start off solving quadratics by factoring. Before we do the 3 examples here on the side, we're going to start off with 2 extra problems that are easier to factor. So the first one is going to be what we call an easy trinomial, and that is going to be x squared minus 7x minus 18 is equal to 0. And what we're going to do when we solve this is when you solve or you factor a quadratic, it factors into two binomials. And then don't forget, this is an easy trinomial because there's no number other than 1 next to the x squared. It would be a hard trinomial if it was like 2x squared, 3x squared, or anything other than 1. But because it's easy, I know the first two terms in my binomials are going to be x. So I can put that there. And then to get my last two terms, I need to figure out what I can multiply to get 18 that will also add to give me a 7 or a negative 7. So I need to multiply to get negative 18, add to get negative 7. So the first thing I do is just start off by listing out my factors of 18. So I know I can multiply 1 times 18, 2 times 9, and 3 times 6 to get 18. Now what I need to do is I need to look at those combinations of numbers and see, to get a negative, I know one's going to be positive, one's going to be negative. And I need a negative 7 here. So can I make any of these pairs of numbers equal a 7? Hopefully you're like, oh, well, 2 and 9. If you do 9 minus 2, you get 7. And that is correct. Now we got to figure out, we need a negative 7, so we got to decide. One number is going to be positive, one number is going to be negative. I need a negative 7, so that means my 9 needs to be negative and my 2 needs to be positive. So when I plug these in, it doesn't matter which goes first, but I'll put my plus 2 there and my minus 9 there. And now our expression is factored. And to solve it, again, using your zero factor property, you set them both to 0 and you solve them. So for the first one, I would subtract 2 from both sides, and I get x equals negative 2. And then here, add 9 to both sides, so I get x equals 9. And then if we write it as a set, my equation is x equals negative 2, and then you put your 9 as well. And again, you're writing it in roster notation because it has more than one solution. All right, and before we get to our 3 examples here, again, we're going to do one more with factoring to look at before we get to these that are sometimes a little bit harder. Not really, but so the next one we're going to do is a hard trinomial that I mentioned before. And we're going to factor, we're going to do 5, then we're going to do 2x squared plus 17b, or excuse me, not a b, an x. Gotta have the same variable there. Plus 21. And I mentioned a couple slides earlier that when I do hard trinomials, there's different ways you can do it. You can do factoring by grouping. You can do the box method. You can do trial and error. You can do the diamond method, I've heard some people say. I do the box method. And we want to have this equation equal to 0. And to do the box method, what you're going to do is first, make sure you factored out any greatest common factors. And if we look at these 3 numbers, there's not a number that can divide evenly into all of them. So we don't have a GCF. But I'm going to draw my box. And in the first box is always your first term. So my 2x squared goes there. I don't worry about signs within my box. I don't worry about the signs of the numbers. My last number always goes in the last box. And then the middle 2 boxes are going to be for your x terms, but we got to figure out what to put there. And how we figure that out is, again, like we did the AC method before. Or we looked at C and the factors of C. Now we're going to multiply A times C. And remember, a quadratic is AX squared plus BX plus C. So we're going to multiply 2 times 21. And we get 42. And we're going to look at the factors of 42. So I know 1 and 42, 2 and 21. 3 and 14, and then also 6 and 7. And now what I need to do is look at those numbers and figure out what combination of those pairs of numbers will also add to give me that 17x, that middle number. And in this case, they're both positive numbers, so both my numbers are going to be positive. And I am going to need 3 and 14. They will add to give me 17. Doesn't matter where I put the 3, doesn't matter where I put the 14, pick one. And they're both positive, so to get the signs of my two binomials I'm going to create, if the 14, whatever the sign of the 14 is, I put it right here, it's positive. Whatever the sign of the 3 is, I put it right here. And now what we're going to do is we are going to factor. And we're going to factor the greatest common factor out of these expressions. First, we're going to start by factoring over first. So the greatest common factor for 14x and 21 would be 7. It's the largest number that goes into both of them evenly. Here, we're going to factor 2x squared and 3x. And 2x squared and 3x. 2 and 3, the GCF is 1. Okay, so we don't need to put that there, but we have x squared and x. And remember, when you're factoring out a greatest common factor, you choose the lowest variable value. So we're going to put an x there. And then next, what we're going to do is we're going to factor up. So we're going to factor 2x squared and 14x. And our greatest common factor there would be 2 for the numbers and then x, because they both have an x. And then we're going to factor 3x and 21, and the GCF there would be 3. So our factored form for this equation is x plus 7 times 2x plus 3, and that equals 0. And then like we did before, just set both equations to 0 and solve. So I'll subtract 7 from both sides. So we get x equals -7. And then 2x plus 3 equals 0. We'll subtract 3. We get 2x equals -3. Excuse me. I'm going to move it up here, divide by 2. And so x is going to equal -3/2. And when we write our answer, x is going to be equal to, and we'll put it in brackets, -7 and -3/2. Oops, brackets, not parentheses. There we go. All right, so now we're going to solve A in this problem, example 1. And the first thing you're probably looking at is 1. We got fractions. We don't like fractions. And the other thing we have to worry about is our equation, in order to work with a quadratic equation, has to be equal to 0. And this equation is not equal to 0. So the very first thing you want to do is subtract 3/2 from both sides so we can make it equal to 0. So right now we have this. We have x squared plus 5x divided by 2 minus 3/2 equals 0. And then what we want to do is we want to go ahead and get rid of that fraction. So remember, to get rid of fractions, you multiply by a common denominator. In this case, it's 2. And you're going to multiply everything by 2. Of course, anything times 0 is 0. 2 times x squared will give me 2x squared. And then if you recall, if I have 2 over 1 times 5x divided by 2, those 2's will cancel out, so we end up with just plus 5x. And then if I do the same thing, 2 over 1 times 3/2, or -3/2, those 2's cancel out, and I'm left with just -3. So now I need to solve this. I need to factor it. It's going to be another one of those hard trinomials, so we're going to solve it with our box method. So I'm going to go ahead, draw my box, and we're going to have 2x squared here, 3 here. We got to figure out our numbers for the x's. If I multiply a times c, 2 times 3 is 6. And I know we can do 1 and 6 or 2 and 3. Now, both of those could give me a 5. but I do have to look at the signs. I need a negative 3, so I'm going to need, or I need a negative last number, so that means my two signs, when I put them in, have to be one positive and one negative. So if I were to do one positive and one negative with the 2s, the 2 and the 3, I wouldn't end up with 5. So I have to use the 1 and the 6. So I'm going to fill those in, 6 and 1. Now I need a positive 5. And so that means my 6 here, if I were to add them together, would have to be the positive value, and my 1 would have to be the negative value to get that positive 5. So now let's go ahead and factor. We'll factor across first. And the GCF for 1 and 3 would just be 1. And then we factor across here for 2x squared and 6x. That's going to be 2x. Now when we factor up, for 2x squared and x is going to be x, and then for 6x and 3 it will be 3. So my factored form is x plus 3 times 2x minus 1 equals 0. And then again, to solve, we set both of those to 0, so x plus 3 equals 0, and 2x minus 1 equals 0. We'll subtract 3. So we get x equals negative 3, and then here we'll add 1. So I get 2x equals 1, divide by 2, x equals 1/2. So if I write my answer as a set, a solution set, it would be negative 3, comma, 1/2. All right, so next we're going to look at b. And again, we have to make it equal to 0. So we're going to start by subtracting 6s from both sides. And I'm going to end up with s squared. And we're going to put it in descending order. So minus 6s plus 9 equals 0. You always want to have it in descending order to factor. This is what we call an easy trinomial because there's no coefficient with the s. So when we factor it, I know it's going to have s, and then it's a minus and a plus. So I need a positive 9 but a negative 6, which means I have to have two negative signs, because think, when you multiply those last two terms, two negatives make a positive. And then if you look at the factors of 9, you can do 1 and 9 or 3 and 3. And I need to have a negative 6, so I'm going to use my 3 and 3. So it's going to be negative 3 and negative 3 equals 0. And then when we solve it, they're both the same. So when I solve it, I only have to solve one of the two. And I'll add 3 to both sides. So I get s equals 3. And it's what we call a double root. It's the same solution for both variables. And so our answer is 3. All right, so now we are going to look at c. And c, we have 5x squared plus 10x equals 0. And the first thing we're going to do here is we do have a greatest common factor that we can factor out. So we're going to factor that out. And our GCF, the number that can divide into both terms evenly, would be a 5x. So we're going to divide that out. So we'll have 5x times 5x squared divided by 5x will leave us with x. 10x divided by 5x will leave us with 2. And the nice thing here is we factored out a GCF. Now our expression is factored. We can't do it anymore. So what we're going to do is we're going to take our two terms here. We're going to set them to 0. 5x equals 0 and x plus 2 equals 0. To get this one, we can divide by 5. But 0 divided by anything is still 0. And then we'll subtract 2. So we have x equals 2 for this one. And if I were to write this in set notation, it would be 0, 2. And that would be our solution set for that equation. All right, so here we are going to solve a quadratic equation by taking square roots. And you'll notice our equation is not written in standard form, which is the ax squared plus bx plus c form, but rather now we have an equation where we have the quantity of 2x plus 3 squared is equal to 8. And when you have this, and if you can isolate your square, like we can here, you can solve this by taking square roots of both sides. So what I would do to solve this equation is take my 2x plus 3 squared is equal to 8, and to solve it, take the square root of both sides. Now when we do this, we do need to account for the positive and the negative square root. So whenever you take the square root this way, our answer, when you take the square root of a square, is going to be 2x plus 3. And then over here, we're going to have the positive and the negative square root of 8. So you want to look at both roots. And you do want to, if you can, simplify that radical. So really, we are ending up with, right now, we have 2x plus 3 is equal to positive or negative. And if you recall, the square root of 8 is the same as the square root of 4 times the square root of 2. So it would be 2 square root 2, because the square root of 4 is 2. And then just now what we need to do is solve for x. So I'm going to subtract 3 from both sides. So I will have 2x is equal to negative 3 plus or minus 2 square root 2. And then divide everything by 2. And then x will equal, we'll write our final answer here, x is going to be equal to negative 3 plus or minus 2 square root 2 over 2. And if they ask for the two solutions, this is them written together because we have plus or minus here with the 2 square root 2. If they ask for each individual solution, it would be negative 3 plus 2 square root 2 all over 2, or negative 3 minus 2 square root 2 over 2. So just two different ways to write out your solution. You can put them together or separate if you need to. Okay, and now we're going to take a look at our second one. And the main thing you want to do before you take the square root is you have to make sure that your equation is, your square root is isolated. So we're going to subtract 4 from both sides. So the equation we're going to take the square roots of will be x minus 5 squared is equal to negative 4. And then we'll take the square root of both sides. And now we have x minus 5 is equal to, and the square root of negative 4, recall, is equal to 2i. So we can say positive or negative 2i. And then we just need to solve for x, so we're going to add 5 to both sides. This one's pretty simple. And we end up with x equals 5 plus or minus 2i, and you want to keep it in complex format, so the real numbers first, imaginary second. Right, the next method we're going to look at for solving a quadratic is through completing the square. And sometimes a quadratic will not factor. It is not factorable, but we can do completing the square to solve it and factor it that way. The main thing you want to do when you complete a square, you have to follow these steps. The first thing is, when you have your equation equal to 0 in the beginning, you want to then take it and you want to move that c term, the constant term, to the other side of the equation. So you want to add or subtract it from both sides so that you end up with ax squared plus bx is equal to the opposite of c. So the opposite of what it was on the other side. Then if you have an a term other than 1, so let's say you had 2, 3, 4, you want to divide the entire equation, all the terms, by that a value, so that you get just an x squared there. And then what you're going to do is you're going to figure out, you have to add something to both sides. To figure that out, you're going to take the coefficient of x. So you are going to take b, because that's the coefficient of x, divide it by 2, and then square it. And that's what you will add to both sides of your equation. Once you do that, once you add b divided by 2 squared to both sides of the equation, your equation will now be a perfect square trinomial. So it is easily factorable. We'll factor it, use our square root principle to solve it, and then solve for x. So we're going to take a look at a couple of these on the next slides so you can see how to do this. All right, so we're going to start here with our x squared minus 2x minus 6. And the first thing you want to do, if you recall, is you want to take it out of standard form and move that c term to the other side. So our c is negative 6, so we'll do the opposite. We'll add 6 to both sides. So now I have x squared minus 2x is equal to 6. Next, if we had an a term other than 1, we would divide everything by that. This one we do not, so that's nice. But now we need to figure out what b is, and b doesn't matter really the sign of b because you're going to square it, it will be positive. B is 2, so we take b divided by 2 and square it. Well, 2 divided by 2 is 1, 1 squared is 1. So now what I have to do is I have to add that to both sides. So I'll add it to this side, and then I will also add it to my 6. So that leaves me with x squared minus 2x plus 1 is equal to 7. And then the trinomial that you have will be a perfect square trinomial in that when I go to factor this, it will factor so that both binomials are the same. I have x squared minus 2x plus 1. The only way to get 1 is to multiply 1 times 1, which will add to 2. I need a negative 2, so that means these are going to be negative 1s. And when you have x minus 1 times x minus 1, we don't write it like that. We write it in simplest form, which means making it x minus 1 squared equals 7. And then from there, just like we just did, we can use our square root principle to solve it. So I'll take the square root of both sides, and I end up with x minus 1 equals positive or negative square root 7. And then we just solve it by adding 1 to both sides. So my final answer is x equals 1 plus or minus the square root of 7. And that is our answer using completing the square for a relatively easy one. B will be a little bit more involved, so we'll take a look at that one next. All right, and now we're going to solve B by completing the square. So the first thing to note with this one, it's nice because the C value is already on that right-hand side. We don't have to move that. But with this one, it is a little different. We do have an A value other than 1. So we have a 9 there. So what we need to do is we need to divide everything here by 9 because you want to get that x squared term by itself. So when we divide by 9, we're going to have x squared plus, now 3/9, we can simplify it. We're going to make it 1/3 x. And that's going to be equal to 2/9, which I can't simplify. Now, we need to take our 1/3 and divide it by 2. To get b, we need b squared, or b divided by 2 squared. So that is the same as here. We have 1/3 divided by 2, which is the same as 1/3 times 1/2, because remember you multiply by the reciprocal, so it would be 1/3 times 1/2. One-third times 1/2, remember you multiply by the reciprocal, so it becomes 1/6, and then we have to square it, and that would be 1/6 times 1/6, which would be the same as 1/36. So that's what we're going to add to both sides. It's not a beautiful problem, but it is workable. We can do it. So we're going to end up with x squared plus 1/3 x plus 1 over 36 equals 2/9 plus 1 over 36. And to add those fractions here on the right-hand side, we want to have a common denominator. So we're going to make our denominator 36. So we're going to multiply that by 4 and that by 4. So we get 8 over 36 plus 1 over 36. That gives us 9 over 36, which does simplify down to 1/4. So right now we have this. We have x squared plus 1/3 x plus 1 over 36 is equal to 1/4. And then we have to factor that. Now, the nice thing is when you're factoring perfect square trinomials, this first sign is going to be the sign of your trinomials. So I'm going to have x plus, you always have x plus, and then whatever b is divided by 2, this 1/6, that's what you're going to have. That is the square root of 1 over 36. That is going to be your term that you're always going to put in there, equals 1/4. And then to solve it further, we're going to take, and this is squared, sorry, we're going to take the square root of both sides, which is going to leave us with x plus 1/6 is equal to positive or negative, and I'm going to split it up so we can rationalize that denominator, square root of 1 over the square root of 4, which does simplify to x plus 1/6 is equal to 1 positive or negative 1 over 2, because that's the square root of 1 and 2, or 4. And then to solve it, we're going to subtract 1/6 from both sides. So now we have, and I'm going to have to erase a little so we have some space. We are going to have make a little more space. We have x equals negative 1/6 plus or minus 1/2. And then what we can do is now just do the math there. We can do negative 1/6 plus 1/2 and negative 1/6 minus 1/2. And because they're two real number answers, when we do that, we end up with x equals, and it's going to be 1/3 and negative 2/3. And all I did was I did negative 1/6 plus 1/2 and then negative 1/6 minus 1/2. And that gave us our solution set. So fractions can be a little hard, but they're not bad. We just have to, remember the fractions are your friends and work with them and you'll be fine. Right, and the last way we're going to look at to solve a quadratic equation is using the quadratic formula. This may be the way that you're most familiar with. And the quadratic formula is great, but sometimes it can get cumbersome. And really, all the ways we've looked at, there are, when you're solving problems, some of them lend themselves to factoring. Some of them lend themselves to completing the square or using the square root principle. And then others, you need to use the quadratic formula. So they really are all good and they all have applications. So you do need to know all the ways. But the last way we're going to look at is our quadratic formula. And if you recall, the quadratic formula is nice because to solve for x, you're only using the coefficients. You're using the value for a, the value for b, and the value for c in your equation. And the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac, and that's all over 2a. And then another thing that you will hear them talking about is the discriminant for the quadratic formula. And basically your discriminant is whatever number you get underneath that radical when you solve it. So if you do the math under the radical, b squared minus 4ac AC, and your answer is greater than 0, that means your equation is going to have two real solutions, so two real numbers for the answer. If your radical is equal to 0, then it has a double solution, so x is going to equal the same thing, but it would be, like we looked at the double solution earlier. And then if your number under the radical is less than 0, then it's going to have two complex solutions. Complex, again, using those imaginary numbers, and they're going to be conjugates of one another. So they're going to be, remember, conjugates of, like, if I have x plus 5, the conjugate would be x minus 5. So the opposite signs there. Okay, and now we're going to take a look at B. B is already in standard form, so we can look at it with A. Now I don't have a number here, so my A is going to be 1. B is going to be 6, and C is going to be 13. So when I enter this into my quadratic formula, I will have, in this case it's not x, but t is equal to the opposite of b, so it will be negative 6 plus or minus the square root of, we will do 6 squared minus 4 times 1 times 13 all over 2 times 1. So when I further simplify that, we will have negative 6 plus or minus the square root of 6 squared is 36 minus 4 times negative 4 times 1 is negative 4. Negative 4 times 13 is negative 52 all over 2. So now I have t is equal to negative 6 plus or minus the square root of negative, 36 minus 52, negative 16 all over 2. And I can simplify that negative 16, so it's going to be t is equal to negative 6 plus or minus the square root of negative 16. Remember, we're going to get complex numbers in there, is going to end up being 4i all over 2. And we do have to write it in complex form, so we're going to separate it. T is equal to negative 6 halves plus or minus 4i over 2. And then when I simplify that, negative 6 divided by 2 is negative 3, plus or minus 2 divided into 4 is 2. So t is equal to negative 3 plus or minus 2i, and that would be our final solution for that one using the quadratic formula. All right, and the last thing we're going to look at is we have Robert, and he stands on the uppermost tier of the seats in a baseball stadium and throws a ball out onto the field with a vertical upward velocity of 60 feet per second. The ball's 50 feet above the ground at the moment he releases the ball. When does the ball land? These are your typical problems you'll see when we throw balls or a rock is being dropped from a building, or just looking at velocity of items and the path that it will follow. And when you throw something, if you throw a ball up in the air, it's not going to go straight up. It's going to go up and it's going to form the shape of a parabola. It's going to, when it falls, it's not going to fall straight down. It's going to be more in the shape of a parabola. So, we're going to look at how we can form an equation from this and how we can solve this. Let's take a look on the next slide and we'll look at how to form the equation. All right, so we want to know when the ball hits the ground, which means our height is going to be 0. Now, to form our equation, we are always going to use the same type of equation. To form it, you're always going to use the equation a negative 1/2 times g, which is going to stand for our gravity, times, and t is our time squared, plus the initial velocity times time plus your initial height, which is h, that should be h to the 0 there. It's kind of cut off, but that's your initial height. So our gravity, we're talking here in feet per second. It may be on Hawks, sometimes they use meters per second, so you have to look at that and convert. But if I start off and I write my equation and I have h equals -1/2 times 32 feet per second times t squared, my initial velocity is 60 feet, so that would be 60 t plus my initial height was 50. Now, -1/2 times 32 is going to end up being -16 t squared. And if we're talking about feet per second, your first a value is always going to be -16 t squared because the gravitational pull is at 32 feet and it's negative because it's falling down. So we have -16 t squared plus 60 t plus 50. And we are going to then, from there, we want to know the height when it is 0. So we have our 0 equals -16 t squared plus 60 t plus 50. And then this one, sometimes you can factor them, sometimes you can't. I typically tend to just go straight to like the quadratic formula for these, especially if my numbers are big. If you can, and you can pull out a greatest common factor, you can do that as well. Like here, I can see I could pull out a -2. So if I factor out a -2, then we would have 8 t squared plus or minus, then it's going to be a minus. Let me put that back up there because we're dividing by a -2. Let me get the minus here. Minus 30t minus 25. And these would be my 8 would be my A, -30 would be my B, and -25 would be my C. We don't have to worry about the -2. So then when I plug it into my quadratic formula, I would have T is equal to 30 plus or minus the square root of -30 squared minus 4 times 8 times -25 all over 2 times 8. All right, and I'm kind of running out of room here, but we would simplify that. We would end up with T equals 30 plus or minus the square root of 1700 divided by 16. And because here we are trying to find the height of the baseball, or not, the time that it takes for the baseball to hit the ground, this is one where I would use my calculator to do the math. And if I use my calculator to find this problem, 30 plus or minus the square root of 17 divided by 16, and it would give me 2 answers, and I would end up with 2 answers. The first one, or one of them, would be T equals -7/10 if I rounded it, or I would have T equals 4 45/100. Now, for this, we are talking time. We are talking the time that it takes for the ball to hit the ground. -7/10 is not going to work. It's a solution to the variable, but it is not a solution to our problem. We need time. We can't have negative seconds. So it's going to take approximately 4.45 seconds for the ball to hit the ground. And that would be the solution to our problem.